Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-4 homework solutions on complex fractions. To simplify this complex fraction, I'm going to start by finding the lowest common denominator of all these subfractions. So looking at numbers, I have a 9 and a 3 in these denominators. LCD for those is going to be 9. That's the smallest thing that 9 and 3 both go into. But we also need to include this fraction up here with the x in the denominator. So that's going to be an x going into my LCD as well. Now I'm going to multiply all of my subnumerators here by the 9x. So 9x over 1 over 9x over 1 essentially. And this is again legal because really what I'm doing is 9x divided by 9x, which is just 1 that I'm multiplying everything by. So I'm not changing any values. So every numerator is going to get a 9x now, all the subnumerators. So we have a 5 times 9x all over x. And we've got a 9x times this 5 over 9, a 9x times this 5 over 3. Now I can go through and cancel some things. These x's up here are canceling. 9 times 5 gives me 45. That's the only thing left on top of the main fraction. Down below now in this lower left subfraction, we've got the 9's canceling completely. So that's 5x left over there. And then we have 9 and 3 reducing to 3 over 1. 3 times x times 5 gives me 15x, and we're subtracting that. Now I have to double check and make sure if there's a little more simplifying I can do. It looks like I can actually combine the 5x and the negative 15x. That's negative 10x in the denominator. And then 45 and 10, I can reduce both of those by 5s. So that gives me a 9 over a 2. And now putting everything together, in the numerator, all that's left over is this 9. In the denominator, I have a negative 2x. For this complex fraction, to simplify it, I'm going to start by finding the LCD of all these subfractions. So taking a look at those subfractions, for numbers, we have a 5, and a 16. So smallest thing that 5 and 16 go into. Let me just start taking multiples of 16 until I find that. So 16 doesn't work, 32 doesn't work. Let's see, after that we would have 48 and 64 and 80. 80 is divisible by 5, so 80 is going to be our LCD. And then for the variables, we have an m in this one subfraction, so I'll put an m in my LCD as well. LCD has everything you need to cancel out all the denominators, because that's what we're going to do on the next step. So next I'm going to multiply by the LCD over itself here. And by that I'm actually just multiplying all the numerators of my subfractions by 80m. So I've got 80m times the 4 up there, 80m times this m over 5, and also an 80m times this 5 over 16. Let's go through and reduce what we can. So up here, the 80 and the 5 can simplify. That gives me 16 over an invisible 1. And it looks like these m's also can cancel out completely. So I just have 16 times 4 for that top left subfraction. That's going to be 64 now, and I'll start building my revised fraction down here. In the next fraction, we have an 80 and a 5 reducing. Again, that's going to give me a 16 over a 1. Now we do have the m left over, though. So we have 16mm, that's 16m squared that I'm subtracting up there. And now down here, we've got 80 divided by 16, which is going to give us 5. 5 times m times another 5 is giving me 25m. And just double checking to see if I can simplify this further. There's no like terms to combine. And in terms of factoring and canceling things out, I could actually factor a 16 out of my numerator. And that would give me, what, 4 minus m squared, which I could break into 2 plus m and 2 minus m. Unfortunately, none of that is going to be able to reduce or cancel with this 25m in the denominator. So I'm going to have to just leave this the way it is and call this one done. To simplify this complex fraction, I'm going to start by getting the LCD for all of my subfractions. So taking a look at what I've got here, there's no coefficients really, at least for like next to x's, but we do have an x squared, so I need to put that in my LCD. And we also have this whole other term of a 2x minus 5. So I'm going to throw that in my LCD as well. I'm not sure if there's something simpler. I don't think there is. So I'm going to go with this. So I'm going to multiply everything by the LCD, and by everything I mean the numerators of my subfractions. So multiplying by my LCD over 1 over my LCD over 1. So I have an x squared 2x minus 5 times the x squared over 2x minus 5 there in that first subfraction. Then the whole LCD is going to be sharing the top with the 3 over the x squared for this second subfraction. And down here I've got the LCD times this 3 all over x squared. This is a big mess, but let's go through now and see what we can get rid of. So these 2x minus 5s can get canceled. X squared times x squared is leaving me with an x to the 4th. Over here in my next subfraction, the x squareds cancel completely. So I've got 3 being distributed to 2x minus 5. And I'm going to go ahead and distribute it because, I don't know, why not? Maybe I can combine it with something later on. I don't know. I have to be careful, though, because I have a negative right here. So this is really negative 3 times the stuff in here. So negative 3 times 6x is giving me a negative 6x. And then negative 3 times negative 5 is giving me positive 15. Down here, we've got the x squareds canceling, distributing 3, positive 3 now. So that's going to be a 6x minus 15. And just taking a look at this, it doesn't look like there's anything I can really factor out and cancel out here. I can't cancel out the 6x 15s because I've got this x to the 4th here. So it looks like I'm going to be done with this one. To deal with this complex fraction, I'm going to find the LCD for all of these 4 subfractions. So let me look at numbers first. I've got 25 and I've got a 3. So the LCD for those, the smallest thing that 25 and 3 both go into, is just going to be 75. And then I also have these u's down here, so I need a u in my LCD as well. So I'm going to multiply all the numerators of my subfractions by this LCD of 75u. So I've got 75u over 1 and 75u over 1. And again, this is all legal because I'm really just multiplying by a fancy form of 1 right here. So now I've got a 75u times the 3 in this first subfraction, 75u times this 1, 75u times the 16, and down here also times the 25. Looks a little bit messy, but I'm going to go through and make things look a lot nicer on this next step. 75 and 25 can reduce to 3 over 1. So we have 3 times u times 3. That's 9u for that first, what used to be the first subfraction. Now for this next one, 75 divided by 3 is going to be 25. So this is negative 25u, and that 1's not making any difference there. And then down here, the u's are going to cancel in this lower left subfraction. 75 times 16, let's see here, what's that going to be? I'm going to go to the calculator for that one. 75 times 16 is 1200. So I've got 1200 down there. And now the u's are canceling in my next fraction, giving me 75 times 25. Let me go back to the calculator for that one. So 75 times 25, that's going to be 1875. And we're subtracting that. One more step I can do, well, a couple steps. So up top, 9u minus 25u, that's going to be negative 16u. And down here, 1200 minus 1875, that's going to be negative 675. I don't think there's any common factors between 16 and 675. 16 is just all 2's, none of which are going to go into 675. We can, however, reduce the negatives here to get rid of them. So 16u over 675 would be my final answer for this.